In this video, we're going to do a halogenation of cyclohexene and what we call a vicinal dibromination. The overall reaction is if you got a cyclohexene and you treat it with Br2, the bromine is going to add across the double bond to give you this. One of the bromine atoms is going to be behind the plane of the molecule, and the other bromine atom is going to be in the forward plane of the molecule as such. If you want to know the overall mechanism for that, so the mechanism is a little more complicated. It really is, anytime you have a reaction in organic chemistry, electrons is going to flow towards a positive charge. So if you can keep that in mind, anytime you do a mechanism, always ask yourself what electrons are flowing where and why. So in this reaction, you have this pi bond here with two electrons. And in your beaker or wherever you're doing this reaction, you're going to have these two bromine atoms connected together, and you're going to have these lone pairs of electrons around the bromine. Since this pi bond has a negative charge, as it approaches this bromine here, it's going to make the charge go from slightly positive, and this side is going to be slightly negative. Not by much, but it's going to be just enough for these same polarized atoms is going to repel each other to the point where this bromine is going to be slightly positive. So these electrons on this pi bond is going to reach out and attack the positive nature of the bromine. So these electrons is attacking the bromine itself. Now, if you're starting to think that electrons are attacking electrons, I mean, you just have the wrong idea in that respect. Electrons are going to flow towards a positive character, and the only way that can happen here is if you have the charge kind of skewed one way or another. So it reaches out and grabs that bromine, and since this carbon here lost a bond, this is going to have a slightly, well, it's going to have a positive charge, not a slightly positive charge. It's going to have a positive charge. And this bromine has these other pair of electrons. So this other pair of electron is going to attack this positive charge. And when it does that, these electrons here that's forming the bond between the two bromine atoms is going to break, pushing or collapsing, however you want to look at it, the electrons back onto this bromine here. So you're going to get this. You're going to get this bromine here, and this is going to have two electrons here, and then you're going to have this bromine atom over here by itself with these four pairs of electrons. So this little cyclo bromo group here is really a very temporary situation, and it is a resonant structure of these two situations. You have a bromine with a positive charge. This is going to be in resonance with this, where this has the positive charge, and the bromine is here. So as you can see, the bromine kind of is attracted back and forth across these two carbon atoms. But in order to represent both of those situations, we just draw this resonance situation here. Let me erase that. So we'll have this bromine, the bromine. And what you're going to have here is a positive charge. Remember, electrons only flow towards a positive charge. So both of these carbons here are going to have a positive charge, and this is going to have the negative charge here. This is an electronegative atom. So it's going to be pulling, having an inductive effect, drawing electrons towards itself, or making these two carbons here be positive. What's going to happen from there is this bromine that we left up here is going to come around to the back side and attack one of these positive charges. It doesn't really matter which one it attacks, because if you have this reaction in a beaker or wherever else, you're going to have it, you know, some attacking this side and some attacking that side. You're still going to get the same product either way. So it cannot attack from the front, obviously, because you got the bromine in the way with this negative charge, and you know, negative and negative is going to repel each other. So it's going to attack from the back side. So one of these positive charges. And when it does that, you'll have that backside attack represented by this little faded line here, and the other bromine is going to stay out front as such. And if I remember correctly, this is called an anti-addition reaction. More than likely, all you're going to need to know for a test is when you have a Br2, or this reaction will also work the same way if you had chlorine. So if you had Cl2, if both of these were chlorine atoms, it would work the exact same way. So you had a vicinal dibromination, it'll be the same thing if you had a vicinal dichlorination as well.